let's move to high performance liquid chromatography. Oops, I forgot to change the titles here. Sorry. Um, yeah, I took some of the content from my advanced analytical chemistry class, but I deleted most of the details. As I mentioned, I would like to give you a relatively general introduction. Now, first of all, liquid chromatography is a separation technique in which the mobile phase is a liquid versus the gas chromatography, the mobile phase will be a gas. And it can be carried out either in a column or a plane, but column-based liquid chromatography is more popular these days. In nowadays, the liquid chromatography generally uses very small packing particles and a relatively high pressure, which is referred as high performance liquid chromatography. So this probably answered your question. We don't call it high pressure liquid chromatography because it's not only about the pressure, it's also about the column designing, the packing, the packing of the stationary phase inside the column. Okay. And a general schematic of the system is you have the column here, and before the column, you need two parts, right? One is the mobile phase, which in this is mostly solvent, different types of solvent, and also you need the sample. So we have this solvent reservoir here, which will go through a pump, which can generate high pressure to push the mobile phase. And here we have the injector where the sample will go in. And the sample will be mixed with the solvent, the mobile phase, and go through the column. And then different analyte will reach the detector at different timing. And then all of them will go to the waste. Okay. So that's the general schematic. So high performance LC is compared with low performance LC, right? If you're trying to compare the difference, the very obvious difference is high performance. The peak widths are much smaller versus the low performance. You have much broader peak widths. And in this case, you will use large, non-rigid support material, and the particle is always larger than 40 micrometer in diameter. And it's mostly based on gravity flow instead of using a pressure to push the movement, okay? But it does have its own applications. For example, if you're in a biochem lab, maybe you have run this type of column to try to separate a protein from a mixture. If you want to purify your product, right? You only want a specific product from your solution. So you can use this to achieve the purification purpose. Yeah. So even though it has poor system efficiency and very large broad, but it's simple, it's low cost, and it's popular in sample purification, especially in the biochem labs. Now, what about HPLC? So HPLC, they use small, uniform, rigid support material. Particle size is normally smaller than 40 micrometer in diameter and usually 3 to 10 micrometer in practice. They have much higher operational pressures, 50 to 350 bars, so that the mobile phase can move faster than the low performance ones. And they have very good system efficiencies and small plate height. And as we mentioned earlier, when you have small plate height, you will have better separation, right? Because the peak widths are much smaller. So here's an example that it can be used to separate a standard mixture of sugars and alcohols at relatively great efficiency resolution here. Okay, and one thing you want to pay attention here, right? So I mentioned that if you want to improve your resolution, theoretically, you can increase your column length so that you increase the N, right? But in practical, the columns are commercial columns and you can buy longer ones, but there's definitely a limit. You cannot manually increase the column length. Then in that case, so the column, the packing, those are already constant there. You cannot change those. Then what can we change here when we are doing a HPLC test? We have this mobile phase here, flow rate, temperature, and detector. So the mobile phase, flow rate, and temperature, all of those three can affect the separation of your system. And while you're designing a new protocol for analyzing a new sample, you will take into consideration all this, and you probably will have to try different combinations of those parameters to achieve a best performance. Okay. Now, quickly to mention fast protein LC, so they have a specific name, HPLC. This is also a form of liquid chromatography, and is mostly used to analyze or purify mixtures of proteins. Okay. You always use buffers as mobile phase because you want to keep constant pH for those proteins to stay viable, right? And the stationary phase is always resin, and it's operated in the cold room so that the structure of proteins being purified is not disturbed. So anyways, the HPLC is a specific technique that is designed for protein applications. And the operation pressures they used are relatively medium compared to the general HPLC, but they can definitely be higher based on the purpose. You can also have different modes. What happens is the protein of interest will be selectively absorbed by the ricin. The other components in the sample will simply flow out of the system. And then you change the buffer gradient, which will help the proteins to be released from the ricin, right? So the buffer gradient is then changed by introducing the elution buffer with the help of buffer blending whips. So you're continuously supplying buffer, but before you add any elution buffer, all the proteins of interest will be absorbed by the ricin, and the impurities are being eluted out. But once that is done, you can start by changing the pH a little bit by injecting another buffer, which will change the interaction between the protein and the ricin so that the protein of interest will be eluted out. Okay. So that's the introduction of different forms of liquid chromatography. We definitely cannot cover everything, every single instrument of liquid chromatography or HPLC in this class. If you're interested, I really recommend you to go to those vendor websites such as Agenate and Fisher Scientific, Thermo Fisher Scientific. They have different modes of HPLC instrument, and you can look into the details to learn their applications, their advantages. Yeah, it's a very fast developed area these days. Okay, so now let's go back to the basic components of HPLC. Just to so we had a very simple schematic of the system, right? Now I just want you to have a more detailed understanding of the components. We said that, of course, the column is the key component here, right? The column is where the separation occurs. So the column is the essential part here. And you can see that before the column, we have a huge system here, which involves the solvent system. In this case, you can see that we have 4 solvent reservoirs, right? Which means that when you're doing the elution process, based on what type of analyte you're dealing with, you can change the component. You can change the component of the solvent. So you can have 4 different solvent stored in those different reservoirs. And by using those valves here, you can control the ratio of each solvent so that the polarity of the solvent can be monitored in a precise way. Okay. And then the solvent will go through this pump. And you can see here we have priming syringe, and yeah, so that's where the sample comes in, okay? Because the solvent goes in here and your sample goes in here and they kind of mix, which will go through this before go to the column. So there's some pre-column setup to remove the impurities or to adjust the pressure kind of lab. And then eventually it will go to the detector.